Hello, my name is Sofia Sjöberg.
And my name is Alva Markelius.
And during the spring of 2022, we were granted with the EUTOPIA EURSS scholarship with the opportunity to visit SJOBERG University in Paris, France, for collaborations on a project that we are currently working on. We both originate from the Applied IT department at University of Gothenburg, and with the help from our supervisor, Robert Lowe, we got in touch with our host supervisor, Lola Canyamero at SJOBERG University to start a new project with influences from our previous works. Therefore, the work that we want to present for you today is called Improving Robot Affect Grounded Language Acquisition with Human Caregiver Using Differential Outcome Training.
So to start off, we want to introduce you to the robot Ricci. This is a robot developed by Poland Robotics in France, and that researchers at SJOBERG University have been working on for a human-robot interaction scenario for robot language acquisition. So this robot is inspired by an 8-month-old infant in terms of its linguistic capabilities. And it also has internal needs. So it can be hungry, thirsty, or curious. And in this scenario, the role of the caregiver or the human is to give the robot the object that matches its need. And the robot expresses its needs by using its vocabulary. And over time, it learns to associate certain words with certain needs. And the objects, as you can see here on the screen, are a toy or a cookie or a thirst to satisfy these 3 internal needs. So this is the really incredible scenario we got to work with when we visited Paris. And what we added to this scenario is something called differential outcome training.
So what is differential outcome training? In short, the differential outcome theory states that reward-related feedback unique to stimulus-response pairings has a positive effect on learning accuracy and the rate of learning. So this is a little borrowed picture from Esteves et al. That visualizes the theory and training very, very well. So as you can see, we have the sample stimulus and then choice stimuli. We also have differential outcomes and non-differential outcomes. So during the setup with the differential outcome, you will have the sample stimulus, which for example is the T. When you choose the star, you'll always get a green token. And on the other hand, if the sample stimulus is the plus sign and you choose the circle, you will always get the red token. If this was non-differential, it could randomize with which outcome you get. It could either be a green or a red token. So basically, the effect occurs when the individual forms association pairs between the stimulus and the response.
So back to our robot that we were working on. So essentially, the robot's software architecture originally consisted of 3 modules, and we added the module here in the gray box, which is a differential outcome feedback module. So like I mentioned before, the robot has internal needs that are dynamic over time. And it also has a visual perception module, so it can actually recognize objects given to it. So based on artificial neural network. And this is the same sort of computer vision used in both the simulated version of the robot and the embodied version of the robot. And like I mentioned before, it also has a phonological module. So it has a vocabulary that consists of 10 different words that are inspired by human 8-month infant. So you can say words like dada or nana. So an infant in the babbling phase, essentially. And when given an object, the robot will give feedback to the human if it satisfied its need or not. And these are sort of the rewards that are differential that we added to this scenario. So when different needs are satisfied, the robot will give different types of feedback to the caregiver back. And these feedbacks are in terms of movements or sounds from the robot. So for example, it is unique movement and sound combination for hunger, thirst, and curiosity. And this is essentially a simplified version of the setup or scenario we developed in Paris. So it begins with the robot expressing an internal need by saying one of these babbling words. The human then gives it an object, and by reinforcement learning or cue learning, the robot will learn to associate or disassociate this word with that object, depending on if its needs were satisfied or not. It will then give differential outcome based feedback to the human back. So this is the part that we worked on mainly in Paris. So in this scenario, the caregiver or the human will learn to associate words with certain objects to be able to faster give the robot what it actually wants. And the robot will learn associations between its vocabulary and its own internal needs.
So just as Alva said, we are working with a mutual learning situation here. And the methodology that we worked on was basically on how to set this up at in the best place, or how to do it in a good way. So what we mainly did was a differential outcome feedback coding. We were doing a lot of research on, for example, how human infants or animals would react when they're happy or when they're sad. So the movements are inspired by both animals and children. And the robot also makes a little robotic sound when the need is satisfied, which could either be negative or positive. And to not make it too uncanny for the human, these are very like bleep bloop, classical robotic sounds. And the independent variable that we were working with mainly was the differential outcome training that had 2 levels. It could either be the differential outcome with movement and audio feedback, which were all unique stimulus response pairings. And we also had the non-differential outcome training. And these were just randomized movement and audio feedback when it got satisfied. So there was no red thread through the whole thing. And what we aim to look at also in the future, because at the moment we have only conducted pilot studies, are convergence rate, average reward, and how the caregiver, what effective responses they have. And we were doing this on the pilot studies, we did this by interviews, but also surveys to kind of see patterns of when they liked the situations and when they were feeling
Confused.
Yeah, exactly. So these were the findings from the pilots that we want to show you. And this was from 6 participants in total. So this is from 3 in each group. And as you can see here in the differential outcome based feedback and the condition, the average reward is inclining, while during the non-differential based feedback, the average reward is quite staggering and doesn't reach any convergence points.
So what we can conclude from our work is essentially that the combination of differential outcome training and human-robot interaction is a promising field of future research. And we aim to continue investigating beyond these pilot studies how it can be beneficial for different interventions. So human-robot interaction seems to be an appropriate medium to elicit a differential outcome effect. And in almost any learning context, this should be beneficial in terms of effectivizing learning, for example, for patients with dementia or even children and others as well. So what is unique with this particular setup is the fact that it's a form of mutual learning. So the caregiver, the human here, sort of adapts, it learns by learning. So it's more of an active learning procedure instead of a passive one, what is more common maybe in most learning contexts. It also seems like the language acquisition within the robot is effectivized by the caregiver being more secure of what to give the robot. And this is also of interest for developmental robotics. So like Sophia mentioned, we conducted some pilot studies that were really insightful in terms of the participants' reaction to this sort of experiment. And they had some really interesting testimonials about how they experienced the feedback from the robot. And we could draw some conclusion of how to improve the setup and the scenario for our future experimentation with the actual real embodied robot, possibly this winter. So what we are aiming to discuss and improve here is For example, the effect of multimodal differential outcomes. So to sort of investigate different levels of sounds and movements and other modalities in how the feedback from the robot can be made more multimodal, and also to increase the differential outcome effect. Different outcomes also turned out to be different indicative of levels of satisfaction or of certain emotions within the robot. So it could be sort of interpreted different ways. And this is something we aim to improve and investigate as well. So in the future, we aim to set up this experiment with the embodied robot in Paris and potentially add different modalities for the robot feedback. And we aim to continue investigating this as a potential future intervention as well in learning contexts.
So to finish this presentation off, we would like to acknowledge and thank Erasmus+ and EUTOPIA for believing in our project and giving us this opportunity. And we would also like to thank Sergi University and Lola Canamero, our host supervisor, and also University of Gothenburg and our supervisor Robert Lowe, who sent us out on this thing and believing in our project. Thank you very much.
Thank you for listening.